Picking up where we left off, type of connective tissue part 2, or tissues part 2. I have a new microphone, so hopefully this doesn't sound all staticky. This little diagram shows a few different types of connective tissues that are found in the arm itself. The fibrous connective adipose, looks like hyaline cartilage, bone, blood, loose connective tissue. So when you classify connective tissues, you base it upon the matrix, that is the extracellular matrix, the stuff which is laid down outside the cells themselves. For bone, they lay down a hard hydroxyapatite or a hard calcium carbonate type of tissue. So the tissue can be either matrix, which has protein fibers. So protein fibers could be your collagen. It could be dense connective tissue, is densely packed with protein fibers. Has a whole lot of protein fibers. You can see them laying parallel. It can be loose or areolar connective tissue, which looks like pickup sticks. They just threw a bunch of lines down there and they're all stacked up, so the protein fibers kind of go every which way. They're loose packed. So it's widely separated collagen and elastic fibers, two different types of fibers. Then we have our adipose, or our fat tissue. It has very little extracellular matrix. If you look at the diagram below, those cells don't have much between them. They got a little bit of elastic and collagen fibers, but mostly the cells are full of lipid. The smooth endoplasmic reticulum has gone to great lengths to convert all that fat that it took in into stored fat that the body can use pretty readily. So the cells themselves look fat, and they are just right up against each other. If you look closely, the nuclei are pushed clear to the edge because the cell is so full of fat. So like, there's a nuclei there, they're pushed to the edge. Whoa, there's a closer up. Alright, cartilage. Chondro means cartilage. Freshman biology, you did classification. Chondriichthyes was, ichthyes means fish, the cartilaginous fish, the sharks, skates, and rays. Here, chondrocyte, chondro is cartilage, cyte is cell. We have three main types of cartilage in our body. The first type, athletes love it, it looks really cool under the scope, is hyaline cartilage. Hyaline is the most abundant cartilage in the body. It lines the ends of your bones for protection. Athletes, especially gymnasts who do a whole lot of high impact, tend to break this up, so by the time they're 40, they've got what's called osteoarthritis, or bone-to-bone contact, because this protective hyaline cartilage at the end has been taking such a beating, it's been damaged, and now the bones are starting to touch. There's fibrocartilage, which has a little bit more collagen to it, it's a little tougher. And there's elastic cartilage, which has a lot of elastin, or elastic fibers in it. So your nose and your ears, again, you can twist those things around there like a rubber band. So the hyaline cartilage, if you notice in the diagram above, it lines the end of the bones. In the x-ray you can see it's clear, so the bones are not contacting. And it helps provide a nice smooth surface, little insulation and shock absorption. Under the microscope, the hyaline cartilage looks like this. I have to call them cartoon characters. That looks like little eyes, a little mouth, a little smiley face, a little spooky ghost there. It's just kind of cute if you make little faces in there. It's kind of cool. It's easy to recognize when you look at it that way. The extracellular matrix all between the cells is cartilage. It's collagen fibers and elastic fibers. So it's bouncy, spongy, and protects the bones. The next one is fibrocartilage. Fibrocartilage has a lot of fibers in between there, the cells, and those run parallel. You can find those in between the discs, your vertebrae discs, that's in the intervertebral discs. Those discs between the intervertebral discs, between your vertebrae, help it shock absorb as you bend and jump and you land hard, so your bones, vertebrae aren't bouncing off against each other. As you get older, those discs will lose water, and they'll slightly shrink a bit, but you take all those discs and the slightly shrinkage, you can lose an inch or two in height. There is more collagen. Again, that's the collagen fibers you can see running parallel throughout the extracellular matrix between the cells. And intervertebral discs between the vertebrae. Alright, there's Brendan showing us his elastic cartilage. And if you look to the right, you can see the little chondrocytes, cartilage cells, and all the elastin fibers between them. And they look pretty spongy like rubber band. So it contains elastic fibers and it's very flexible. Twist your ear around like your mama did when you were bad. Now the bone. The bone is so easy to tell under a microscope. It has mostly mineralized matrix. Hydroxyapatite is the name of the mineral that the body takes the calcium we eat, combines it with some phosphate, and you get these strong, solid fibers. Now it's also reinforced with collagen and elastic fibers, so bone doesn't necessarily snap. Those help give it some bendability. Alright, and blood. Blood has a fluid extracellular matrix. Probably the only connective tissue in the body which has a fluid extracellular matrix between the cells, plasma. So look at the picture, you've got the white blood cells, these big purple ones. The red blood cells, or erythrocytes, are these little biconcave disc things. And then the little tiny specks are the thrombocytes, or platelets. Little practice. Sarah gets her ear pierced. She proceeds to tell the dude with the wicked nose piercing all the tissue layers in order that she is sticking the needle through. Can you list all 6 layers the needle goes through if she's letting her upper ear cartilage be pierced? So, a little hint behind you. You've got the part of tissue which covers and lines the body. Covers upon with the epi, because your outer ear is on the outside. It's probably stratified squamous epithelium as the picture behind you. Once you get under the stratified squamous epithelium, you get down to the dermis, which is below the stratified squamous epithelium. The dermis is made up of a connective tissue. So you get the loose connective tissue, the areolar connective tissue. We call that fascia. You're going to feel that and sense that when you take the skin off your cat next month. Then, within that, you've got blood. So the capillaries, blood is also a connective tissue. It connects. Then you have elastic cartilage. In the middle of the ear there, poking through, that is elastic cartilage. It bends, needles popping through that, coming back out, it's the same route back out. You go back to the blood and the loose connective tissue, and then back to the stratified squamous epithelium, and you're outside again. So blood is in there throughout the areolar loose connective tissue, so it's all kind of mixed. So another type of tissue, a third main type of tissue, is muscle. First type is epithelial, second type is connective, our third type is muscle. It has the ability to contract. There's 3 types of muscle tissue we're going to talk about. So there are contractile proteins. The 2 main contractile proteins in muscle are actin and myosin. Boy, those are big and bold. Actin and myosin are the main contractile proteins. They form a little ladder-like work in there. The myosin has little tiny heads which will grab a hold of those actin fibers, and they'll pull them together and shorten that wide little ladders, if you will, bring it together. And you got hundreds of those going across in one muscle fiber, one muscle cell. And when they shorten, that whole muscle cell shortens. Then you take that into whole muscle, then you've got huge shortening of the whole muscle, which you can see visibly. Again, every one of those little lines going up and down is has actin and myosin between it. So these lines on the side, these ladder-looking rungs, would be these striations, or these lines here. So those are closed together. This happens to be the skeletal muscle in the background. So the first type of muscle we're going to talk about is skeletal muscle. Skeletal muscle makes up roughly 40% of your body weight, depending upon male or female, weightlifter, non-weightlifter. They're under voluntary control. Skeletal muscle is called skeletal muscle because it attaches mainly to the skeleton, but it's something we control. We can choose to raise our arms and legs. We can choose to smile. We can choose to wink our eyes. So those are all under skeletal muscle control. They're voluntary. There are several nuclei per cell. This one down here is 1, 2, 3, 4, 5, 6, 7, 8, 9. 9 nuclei in just that one fiber there. So it's a lot of nuclei. It is striated or banded due to what two fibers? What two protein fibers? Because of A and M, actin and myosin fibers. So the smooth is under your control, you voluntary control. The next type of muscle we're going to talk about, you have no control over it, it just happens. It's called smooth muscle. It's called smooth muscle because you can see the muscle in the background. It's got one long nuclei into one spindly shaped cell. There's no striations. Smooth muscle does not exhibit striations. Striations are those little lines caused by the actin and myosin filaments, or the system that set that up. Okay, smooth muscle lines the walls of hollow organs, skin, and eyes. It is involuntary. You have little tiny smooth muscles wrapping around your superficial blood capillaries. So when it gets cold outside, like I told you first unit, those smooth muscles will contract and they'll squeeze that capillary so little blood goes up to the surface and you keep it internal so you can stay warm without losing heat. There is one nuclei per cell. Single nuclei per cell. It is not striated. Okay, cardiac muscle is heart. Heart is cardiac. You can see they branch off. They are striated, got little striations in there, but they branch and connect. Part of the reason they connect like that is so they can all beat uniformly together. So it's in the heart. It's involuntary, yet striated. And has intercalated discs. These little things you can see right there, those are the discs, and they're intercalated, they're shuffled throughout, intercalated. Okay, last but not least, nervous tissue. It's like the brain, the spinal cord, nerves, and it communicates by way of electrical signals called action potentials. Don't forget it, action potentials. It's coordination and control of the body activities. So, the neuron is the nerve cell, and it has axons, axon, dendrites, and cell body. Around the dendrite, you have this myelin sheath, which acts like an insulator to insulate, so you don't have a short, basically, of the electrical signal leaving. So it helps that electrical signal zip straight through to the end. So you got your cell body, your dendrites, and your axon. The dendrites reach out, the axon is a long little piece of the cell surrounded by a myelin sheath. The myelin sheath is like the insulation electrical cord, like I said, and it keeps the action potential in. Multiple sclera, or many cuts in the myelin sheath, cause a short in the system, so your brain sends a message to walk. The message doesn't quite reach the leg muscles, and you stumble. That's called multiple sclerosis. With that, we end the 4 types of tissue. This will end then part 2 of tissues, talking about the main tissues. Next, we'll talk about the membranes around them, cancers, and stuff like that.